Jesse.
Yes.
And we're recording.
Okay. Let's see.
All right. Let me start with introducing Jesse from my side first. Jesse, this is for the recording purpose, if you don't mind. All right. Good evening, everybody. Welcome to our PyData, Triangle PyData July event. Today, our speaker is Mr. Jesse Eversole, and Jesse is currently working as a cybersecurity consultant for ImageX Consulting on contract to AIG, where he serves as a team lead in cybersecurity vulnerability management. Jesse is a career software engineer and IT manager whose experience with data science began by integrating predictive modeling technologies into marketing campaign management platforms. Following his work in marketing analytics, Jesse began working in the data-intensive discipline of cybersecurity, where he currently focuses on problems in the area of vulnerability management. Jesse holds a bachelor degree in chemistry and mathematics from Morehead State University and a master degree in computer science from the Georgia Institute of Technology. Extended profile can be found later. If you're interested, please contact our Triangle PyData. We'll be happy to supply that. All right, it's all yours, Mr. Jesse.
Thank you so much. Okay, let's see if I can share my screen. I'm not a big fan of Teams. Let's see if this works. Can you see my screen?
Yes, we can.
Yes, sir.
And so, how many of y'all know Gene Ferruza? I assume most of you. He got a hold of me and he said, do you want to do something on cybersecurity? And one of the things I wanted to say to the group here is one of the things that we care about in cybersecurity is awareness. So depending on the awareness in the group, much of this is going to be about awareness, and then we can talk about graph databases. So there's going to be more on awareness and less on graph databases, and we'll see why later. So from an awareness point of view, I thought it would be good to let you guys know what's going on in vulnerability management, why, how, and what, graph database technology. We can talk about graph database technology and why a graph database and how it might apply to vulnerability management. But I will tell you that I think that a lot of existing products that are out there now may be using graph databases, but traditional database is primarily what I've seen in my experience. At the top of the food chain is the Common Vulnerabilities and Exposures database that's maintained by MITRE. So for all of us, that look at our federal government as a central funding agency, one of the things that you may or may not know, this database is central to just about all of the efforts that go on in large enterprise vulnerability management. So what's going to happen is if somebody hacks a particular system, that hack will be identified. It will eventually make its way here, and then you will see that. And if you're an enterprise, you will be tasked with understanding whether or not you have that vulnerability and what to do about it. So if you think about malware and ransomware and that sort of thing, many of the, just about all of those are associated with what a CVE. And your job, if you're on the inside, is to determine what CVEs that you have exposed in your environment and what you're going to do about them. And that's not necessarily an easy problem. Just because you find out about it doesn't mean that you can easily fix it. And that gets us to, wow, now that I know that all these vulnerabilities exist, how do I manage, what does it mean to manage them? And I got this, and these are my Google search. I've gotten tired of writing these up myself, so I just go get them off Google. Uh, but it is a cycle, and you can imagine that you're managing an IT shop and you got to classify, prioritize, remediate, and mitigate because your software is always changing. You're getting notifications of vulnerabilities literally on a daily basis, which I was dealing with today. And um, it's an ongoing process. So it is data intensive, and hence, taking a look at if I'm going to manage backend database model for this particular problem, how does it play out? But this is also about awareness of cybersecurity and what it is we have to go through every day in, day out for vulnerability management. Mind you, the government, all enterprises, everybody has to do this at scale. So I went and dug out, there are 5 million different diagrams for uh, vulnerability management lifecycle. I pulled this one. These guys happen to be out of Huntsman in Australia. Some have 5, some have 6, but literally you discover, prioritize, access, report, remediate, and verify. Now, and then I added some arrows here because verify and remediate has its own cycle, and prioritize and assess has its own cycle. So they didn't put that in there. So I added that because I know that's there. Um, Discovery is from multiple sources. So researchers, the government, announcements from Microsoft, there's countless different sources from where you can discover that day that now there is a new vulnerability to any given system on any given software in your environment. And uh, it's like watching the news every day. I mean, it's like intelligence. So the question is, because you get a bunch of these coming in every day, what's the risk? Because how many are you getting? How much? How what's the risk? How do I deal with it? Evaluate the scope. Um, you've got to report on it, and then that depends on the size of your organization. But you really need. I mean, it's like the White House intelligence briefing every day almost. It certainly is for me right now because that I sit in those briefings. Remediate. Okay. How am I going to fix this thing now that I know about it? Where is it, and what am I going to do? And well, then how do I verify that I got it fixed? I mean, just because somebody says it's fixed, do I check on them? And that's kind of like regression, and it's not unbelievable. What I can tell you is you can always introduce an old vulnerability into anybody's environment in today's modern virtual environment by using a image from, say, a Linux or Windows image that you got, and they let you put it in there. It'll have, and you put it on the network, boom, it's got a vulnerability in it. So continuous verification is a part of this game. It's just the way it works.
Jesse?
Yes.
That brings to mind, it reminds me of automated testing and test cases. Are you going to speak to that later on? Or we can invite you back for test
Yeah,
cases.
I mean, we're starting to go down a rabbit hole on that. Okay, so, but when you talk about automated test, we'll talk about that a little later. Keep that in mind and remind me. Okay, in terms of automated test cases, because that's more on the development side in the area of what we call SAST and DAST, where we test software for whether it has vulnerabilities. But what if we get software in from a third-party vendor in a supply chain? How do we detect vulnerabilities there? And we'll talk about that.
Okay.
So that plays into these use cases here. You know, CISA orders agencies to patch Windows LSA bug. These come in every day. So this one came in on the 1st of July. Multiple vulnerabilities in Google Chrome. All right, so you're deploying Chrome across your enterprise. How do you get it patched across all your endpoints in your enterprise where Google Chrome is? And I couldn't resist this one where Python packages caught sending stolen AWS keys to unsecured sites. And that was in June, so late June. So, okay, so what I got to do to run that down in an enterprise of 150,000 endpoints, and who's using Python and who's using PyPy? I bet some of you guys are. So, so if I'm the security guy and I come over to you and say, hey, you've got, I found that your machine has, and we'll talk about how I found that out later, but you got compromised or a vulnerability in your Python libraries on your machine, you need to go patch it. And so I thought this one came out yesterday and is on the radar screen. Both of these. Microsoft has what they call Patch Tuesday, and they do it every month. And so they come out and you get a bucket of patches, and then the organization is saddled with, how do I take all these patches and figure out how to get them in my organization? Do I and what you were talking about, I think it was Mark that brought up the question. Yes, there are big issues with testing because I can't go take a big patch list like this and deploy it across an enterprise and be safe. So I've got this real trade-off where there could be a 0 day in it, like CISA. CISA came out like yesterday and basically said, we got a Windows 0 day and we're requiring all the government, anybody that's got Windows in the government, to patch, according to this CVE. So the CVE is really important because that's your key to what they're going to track the vulnerability against, that you need to be able to prove that you got your patch in there and you no longer have that vulnerability in your system. It's it's an interesting problem. So these came out yesterday, and trust me, they come out every day. So large IT departments have a big problem with this because they've got all of their software running any one of these patches that they put in could break their software. And so how much time does it take to test it? And how can they figure out whether whether this patch is going to break their software? We'll save that conversation for later. But you get where I'm going with that. So when you get one of these and you're in this cycle, what's my risk exposure is one of the big questions. So one of the things that we're looking at is evaluating how easy is it? Is it externally facing? Is it only on the inside behind the firewall? Uh, how many of them have it where? Because in a larger enterprise, that it depends on where the vulnerability is. So it's a complex problem. And again, how do I know for sure? If I do, where are they? How do I fix them? That's a huge problem. And how do I verify that they are fixed? Because it only takes one to be open. Because if a hacker gets into your environment, then they can scan your entire environment. And once these CVEs get released into the open, all the bad guys know about them. So let's just say a researcher goes out and says, "Hey, I found this vulnerability," and those are often called proof of concepts. And then we have what's called is it has been exploited in the wild. So once something's been exploited in the wild, which means is some China, Russia, whoever has figured it out, it's on the dark web, you're exposed. And whatever attack that they want to do, they're going to exploit the vulnerability and then deploy whatever payload that they have. But and usually they exploit a payload or a vulnerability to deploy a payload. If if I fix them, how do I verify they have not returned? And the reason I put that in there is because again, we deploy images in the virtual environment now that we don't pay close attention to that regress the system. So they've got vulnerabilities in images, and this is a known problem where I'm not keeping good track of all the images that allow my engineers to deploy in my environment, and they're not scanned well. And boom, I'm putting them out, connecting them to the network, and they got known vulnerabilities in them. If you've got a bad guy around, they you're exposed. So I thought I would put up a diagram of the home network to give you some idea. And it's just like I look at this and I go, wow, what if I wanted to collect data from all these devices, put them in a database somewhere, and then try to figure out if they have vulnerabilities in them? So we used this diagram previously for how to, use firewalls to protect against video games with my son. But each and every one of these devices you see here can be reporting data into a central database such that you can analyze that data and then uh, try to determine the first thing. What we're going to look for is vulnerabilities. So you're going to want to look for what software do you have on it, uh, and look back to the central databases and compare that against whether you have a vulnerability or not, and then tell you, okay, you're flagged. You need to fix this. And it could be on any one of these devices, and it could be anything on those devices. And it could have a severity associated with it in terms of how hard it is to be able to exploit that vulnerability. So, as you might imagine, there has been no shortage of vendors that operate in the space at the enterprise level. This is just a sample of them, but these are some of the bigger ones. Qualys in particular, ServiceNow, you guys may know about. ServiceNow is IBM product, and what they're used for primarily is what we call a configuration management database. It's a lot of this has to do with asset management so that you know all the devices you have deployed. Kenna got bought out by Cisco, but what they do is they also get information on what the risk is if they find a vulnerability. Tanium is a device. It does file integrity management and remote uh, code execution on your devices, but it knows what you've got on your machine. Qualys does. Veracode is a um, software analysis tool that knows about what your software is and can analyze it for vulnerabilities that can be detected by doing scans of source code. That's what Veracode does. Palo Alto is a firewall company, but they also are able to give you information on your network and how your network is laid out. Tenable is equivalent to Qualys. Tripwire is a configuration management tool, and BitSight is one of these guys that goes out and analyzes externally and actually publishes a score on your company as far as to what ports and what your if you guys hear thunder and stuff in the background, we're um, BitSight is a company that actually rates your security with regard to your externally facing interface to the internet. So they will scan you and give you a score and say, hey, you're not very secure or you are secure.
Hey, Jesse, sorry to interrupt, but we do have one question pop up in the chat, if you don't mind. Do you feel like go all the way to the end of the presentation, or it's okay for people to ask question in a way?
No, yeah, go ahead, raise the question.
Sure. I'll read this question. Does Jesse have any recommended sites to keep informed on these issues for people that are interested but do not always dive into the CVE database? Offhand, what Taylor was the one who asked this question. So Taylor enjoyed looking at cribsonsecurity.com and darkreading.com. So any recommendations?
Let me make sure I understand that. I don't know if I know the exact answer to you. Are you asking for my recommendation?
Hey, sorry, are you there? Can you hear me?
Yeah, go
Yeah,
ahead.
so we can wait till the end, but I guess I'm just curious in terms of like for people who are interested in cybersecurity and these CVEs, but like want to keep informed, but don't necessarily you know it's not their day-to-day life kind of thing in terms of like just general like websites, like aggregate websites. But we can wait till the end if you have some recommendations.
Well, I have what I call trade rags, and it depends on what your objective is. But I have a collection of about 12 to 13 trade rags. In the old days, hopefully you may have heard that thunder. And if you want to stay up to date on the latest stuff, this collection of I hadn't thought about that. You brought up a good point. I can publish I can give you guys links to all of these websites. They're all public. And if you want to look at them every day, they cover a lot of different things. So, but some of them stay up to date on the latest, and some of them talk about other topics. A lot of times, I'm mostly concerned about what the latest vulnerability is and how it affects me. That a lot of times they'll be talking about, some phishing campaign, or whether uh, what China group, the various names of all hacker groups and all that stuff. If that's what you're interested in, then this group of links I hadn't thought about that, but if you
Yeah.
want that group of links, I can make it available.
I'd
They're-
be interested in that. Thanks.
Yep. Is that what you were after? Something like that?
Yeah, that's exactly what I'm after. Is like basically someone who's in your domain, that like what you read kind of thing. So
Oh, yeah. Oh, yeah. Well, this group of links, will keep you busy. If you wake up in the morning every day and you start going through it, it will keep you busy. So now, from a database point of view, this is a very simple diagram that I assembled. I could complicate it off the chart, but I can apply this to generally to any problem. But all of these applications that we use in vulnerability management all have databases. And one of the problems with them is that, they're their own database. They don't work together with each other, and they don't have interfaces. So what you'll find when you get in these enterprises is everybody does an ETL over to a central data store, and they use some BI reporting tool, which is okay. Now that you're in that central data store, how are you going to store that data? Because I'm going to assemble all this data. So let's take a look here. See if I know how to go back. Oops. Sorry about that, guys.
No worries, Jesse. Take your time.
Let me stop here for a second. I hit the wrong button, folks.
That's all right, Jesse. I see Dave
Where
comment on the some codes that he was using for vulnerability detecting. Dave is using HP Fortify SCA to scan some of his code for vulnerability. I think that's one of the best practices in Google, Dave.
I'm having technical problems here. Is Dave online? In terms of software scanners, is that what he's talking about?
Yes, I think Dave was talking about the HP Fortify.
Fortify. Yeah. So Veracode, Fortify, take your pick. With regard to if you're going to do what is software application security, SAST. So DAST is dynamic after you do it. Is my screen off now? Or can you see my screen?
Not yet, Jesse.
Okay,
Not yet.
hold on. Teams. Okay. Yeah. How about
Yeah.
now?
Yeah, we can see your screen
Now,
now.
so with regard to when you're a developer and you're building code, and let's just say you're going to release it into a production environment in an enterprise these days, you're going to run it through somebody's SAST scanner if you've got a reasonable, security environment installed. And the reason for that is because developers may not be security conscious. So what will happen is when you go through these scanners, they will come back and say, hey, you can get a SQL code injection vulnerability here, or cross-site scripting, or that kind of thing. So the technology is advanced to the point to where software code scanners or software code, like, and they look for like anything that tries to pick up a password or that kind of thing. So yeah, that's moved along pretty far. I mean, it's not perfect, but it's a lot better. And the thing is that you want to go through one of the scanners and you want to put it in the hands of the developers ahead of time to say, hey, you just go scan this stuff yourself before you give it to me, because you're going to have to go through a gate to be able to get your code into production. Does uh, did that answer? Did that make sense?
Yes, yes, Jesse, it does.
Now,
Thank you for that.
the particular white hat's one of them. I mean, there's several SAST tools that are out there, and that depends on who. You can probably go find some open source ones that will scan your code if you don't have a lot of money to pay some of these big guys. Uh, so it depends on the size of your enterprise and that thing, if you're going to do SaaS. But I recommend it to anybody, just go get an open source one. If you're going to release some code out on the net, to have it look at it. There, and I haven't gone out and done a scan on, I bet some of them will actually do it online and make you sign up and everything, and then try to give you a scan of your code. That's kind of what they'll do, is they will tell you if your software has a vulnerability. What's interesting about that is this is code that you just wrote and it's got a vulnerability in it. So what would happen is if you release that code into production, it would end up being a 0-day. Somebody comes along, you're sitting on an API port, somebody's going to hit that port and send you some stuff that you're not prepared for. You're going to have a 0-day event, if that makes sense. And they know how to do that. Trust me. So with the back to this diagram, you got a central database. How's it organized? Me personally, right now at the level I work at, I don't care, but we'll get into that. But I need my questions answered. So there are a lot of different data fields that we care about, but I wanted to keep it simple here. And if I had, say pick four, what fields do you care about? And when I use the term endpoint, what I mean is anything that's connected on your network. I use the term endpoint. That's what Tanium uses. Some people call them servers. Some people call them workstations. Uh, but you can have mobile devices, anything that's connected to the network is an endpoint. What software is it running? Who owns it? And do I have a vulnerability on that? Now that I've learned that we have a vulnerability, if I got those 4 fields right there, I can go a long way in vulnerability management. And so I thought, hey, I'll write a SQL statement for that if I had all those 4 fields in one table. Select endpoint and owner from my vulnerability table where vulnerability equals CVE of concern. Now, all of those products that we talked about before have other IDs in them and can be much more useful, but I'm just using the CVE as the central key here because when you go to the CVE website, it will tell you what the vulnerability is, what a risk ranking score is, and, you know, generally how to fix it, like patch it. So what I want to know is, you know, do I have this vulnerability on my estate, on my endpoint estate? That seems like a really simple SQL statement off of a very simple table. And to be honest with you, it kind of is. Now, when I went out and looked at graph databases, I said, why would I organize my underlying database? And I pulled this from Neo4j, and it's not related to, but, and I'm going to allow people to kind of extrapolate. But when you look at the way a graph database is put together, relationships and properties and attributes, and you want to put a node in so you can say, well, that person there, that's an endpoint and it's connected to this other person, but, and how are those endpoints connected? And the software, maybe the car, who owns it, and where's the vulnerability? So I put this together pretty fast to leave it to your guys' imagination. But where I'm going with this, if you're going to design a vulnerability management database so that you will get, what are you going to get out of it? Well, the end, and I got this from Neo4j as well. The endpoint has software, the latest Windows nasty bug, and owned by some person in Ukraine. So, you know, that kind of statement is not necessarily as easy to express in a SQL statement. So when I was looking at it, I was saying, well, that may be some value that a graph database brings to this problem. And then, well, that, well, you know, now I have to go build a graph database in addition to my traditional data warehouse, which has a bunch of tables in it that have a bunch of keys pointing all over the place, pointing to these entities. So conclusion is, you know, the data model is up to the implementation engineers. Do you need more performance? In this particular application, I'm not sure performance is like it is in big, large marketing applications with huge databases. The databases are large, but you can sit around and wait if you get the right data that you want. Ease of use with the right, being able to answer questions that you really need answered is important. And an effective query language that you can easily communicate. So you can think about, wow, I need to bring some new people into my department. Well, how am I going to explain this query language to them if it's a hard to understand query language? Because is it expert friendly, or, you know, like we used to say in Linux, oh, that's expert friendly. So yeah, I know the Linux command line and all that. How long does it take me to teach somebody the Linux command line? Can be a while, right? So user interface is always an issue. So if you want to plug in some BI tool to it, be ready for that. And when I looked at this, and and I didn't go into trying to design, remotely design a graph data model for the problem that I'm talking about here, but I did go to the point to say, yeah, it'd take me some time to try to build all this out after I looked at some of the Neo4j simple examples. ETL to a graph data model is always going to be, ETL is always a problem. So you've got to get the data model together and then figure out how you're going to write your ETL to it. So you're likely maybe going to have to do that by hand, I would say, at this day and age, because maybe there are some tools out there that you can give a graph data model to an ETL tool and pull it. Most of the data sources that you're going to run into in this problem space are going to be flat tables. And you're going to have to be able to figure out what the relationships on those flat tables and figure out how to tell ETL to do the right thing and build up all your nodes and your relationships. Integrating that between a traditional data model, I think, is going to be a challenge. And at my point right now, and I could be behind on this, but I think it's going to remain a research issue while traditional data models dominate. They're already in place. Somebody's going to have to show some serious value because I don't think that we're going to see any kind of common graph data model based vulnerability management database come out. Somebody's going to have to go in and say, here's the value proposition, let's build one. Game on. Questions? Comments, concerns? I'm done.
Thank you, Jesse, for awesome game on presentation. It's our Q&A session. If you guys would like to ask questions, we have 5 minutes.
So Jesse, did you go ahead and implement a graph database for tracking this, or did you stick with relational database?
No, I mean, I work with a massive relational database every day that other people build. I mean, they're massive, right? 200, 300 tables.
Ugh.
Something like that. Yeah. So if you're going to build a graph database, you're going to have to figure out how to do all your nodes in the context of that. You know, a bunch of people that have done a bunch of entity relationship diagrams between all of these essentially products that if you do an API interface and you do an extract, what's going to happen is you're going to get a flat table, right?
Right.
That you would put it in like an Excel spreadsheet. Now you load that, you figure out what you care about in that, and you load that into some relational table, and then you figure out some entity relationship from there. What's interesting about graph is what if I did that a little bit different than an entity relationship diagram in a relational table context? Would I be able to get better answers to my questions? That's what needs to be explored because I have my data in a different organizational model.
Gotcha.
That when I looked at this problem, that's what came to mind.
Yeah. I guess a comment that I have is that Neo4j does have a substantial, well, more than one, more than one way to import data, whether it's flat CSV files or from a SQL Server relational database. So there are multiple ways of getting your data into a graph database. I do agree with you that you've got to set up some thought ahead of time, going, what kind of nodes am I going to have, and how will the nodes relate to each other? That does take some thought. But the nice thing about graph databases is you can prototype fairly rapidly with it.
Yeah, and I spend most of my time right now asking questions rather than designing the back end. So I certainly agree 100%, and that you really sparked my interest when you asked me to come and speak on this. So in some respects, whoever's in the room that knows how to do that, I would love to collaborate with them, because the problem space sits out at the question level.
Well, I'll tell you what, since I'm on a bit of a graph database kick in the 2022 and 2023 time area, this year and part of next year, I want to introduce graph databases and then graph database for data science to this group. I do have some contacts, and I will be in touch with you and put you in touch with some people who can help you.
Yeah, it's in my opinion, it's a problem space with regard to the underlying data model and the higher level problem space to explore. I think some of the one of the things that's interesting is I think some of the actual tools that are out there based on the query languages that I'm looking at, like Tanium, Wallace, when I looked at some of the Neo4j query language and stuff, I think they themselves may be using some graph database technology for their own database management. The thing is what we're doing in vulnerability management is pulling extracts from all those guys. So I don't care about your query language. I'm pulling data from all these different sources and assembling it to solve this other greater problem based on the specific data that you have. None of them have the same data. They have overlapping data, but they don't have the same data. So you could envision it like, okay, I got 5 different consoles, and I'm a human being, and I go to 5 different consoles to answer a question, and I pull extracts when I do that from the reports and put it into an Excel spreadsheet. And now I go out and do a bunch of pivot tables to try to get the data the way I want to see it. And it comes from 5 different sources. So that is a huge problem because it is totally manual when you need to be able to define this is the question I need to answer from those 5 different sources. Do I pull an extract into a node database, and then that makes it easier for me to answer that question? That's been on my mind.
Right. And like I said, I will put you in touch with some people who can help you answer that question.
I look forward to it.
All righty. Thank you so much, Jesse, for the awesome presentation. A lot of good stuff and new knowledge we obtained from this session, and thank you very much for that. If no one has more questions, let's proceed to our next part of today's event.
Yanlei, can I introduce the first lightning talk?
Oh yeah, absolutely. If you'd
I'd like to introduce Stan, and I will hopefully get this right. Stan Ahalt, who is the new dean of the School of Data Science and at Chapel Hill. And so Stan is here in the participants list.
I am here, and can you hear me okay?
I can hear you.
Good.
Yes.
I'm trying to turn on my camera, but unfortunately, since I don't use, well, maybe that's close enough. How's that work?
We can
so-
see you.
Very good. So I thought that was a very interesting talk, and I want to tell you about this new School of Data Science and Society that we're launching at UNC Chapel Hill. And I'm hoping that you all can both spread the word and also perhaps give us some advice in the relatively near term on types of things that we need to teach our students to be, very much the cutting edge data scientists that we need, here in the Triangle, here in the state, and here in the nation. And I can tell you that I spent at least 2 conversations today talking about knowledge graphs. So this is an area near and dear to my heart, and an area that I definitely want to see embedded into the curriculum of the new school. So about 10 days or so ago, I was named the inaugural dean of the new School of Data Science and Society. So I just wanted to briefly share my vision for what we're shooting for in creating this new school, and then open it up to some questions. I'm trying to make sure I stay at 5 minutes. So I have been primarily focused on research that's focused on large team science efforts. So we do a lot of collaborative research with groups that are across the country, and sometimes multiple continents. And that was all being done as my in my role as the director of RENCI. RENCI is the Renaissance Computing Institute. I would not be surprised if some of the RENCI folks were on this call tonight. I know there's some active participants from RENCI, but we do have about 100 people working at RENCI. It's not a big organization, but it is a potent one, and we end up doing a lot of very interesting research for various sponsored research sponsors, including NIH, NSF, DoD, et cetera. However, I was trained as a educator, and so this is a full circle moment. I'm returning to activities that I really love, and that's in particular is reaching out and interacting with students. And so even though my research for the last 9 years has been focused on solely on data science and making sure that it becomes a modern science, a keystone of modern science, I'm really very excited about this opportunity to start a new school and start producing the types of undergraduates, graduates, master's students, and PhDs that hopefully folks here in the Triangle and in the state of North Carolina can be using and employing. And I think hopefully we start a new process in the Triangle of being known as one of the greatest locations in the United States for data science. So our objective is to create a very unique program in data science that focuses not just on the fundamental science, but also on the methods and the technologies, including things like graph databases, which I would say right now is one of the hottest topics out in academia and in industry. And those, the underpinnings are the technologies that a lot of us are using here in the Triangle in different places, and lots of times we don't get to talk about it as a collective. And I hope this is an opportunity for us to act as a group that has a lot of focus on data science. So we're going to focus the school on the breadth of activities that are represented at UNC Chapel Hill. That's the reason we named it the School for Data Science and Society, because UNC is not a predominantly engineering school. It's more of a liberal arts university, but that does not mean that we cannot contribute substantially to the scientific and engineering opportunities that exist around data science. So I'm hoping that we really end up being a school that's applied, translational, and convergent, and uses foundational tech advances in theory, but also methods and technology, and being able to bring together students and staff in the sciences and other disciplines in the humanities that really are some of the big challenges for our society right now. And particularly, data has become central to issues in our democracy. Data is at the center of issues around crime and vulnerability and disinformation, as well as opportunities for understanding climate change and how it might affect health patterns. So the sky's the limit here. So we are hoping over the next few years, and we're trying to do this very rapidly and starting hiring faculty immediately, as far as I'm concerned. And we're going to try to be very inclusive about what we mean by somebody who is a data scientist. We're not going to just pick people out of computer science or statistics or computational areas. We're going to include mathematics. We're going to include epidemiology. We're going to include bioinformatics. We're going to include social sciences. We're going to include political science. The list goes on and on and on, including the humanities, because I think there are clear opportunities in the humanities for us to be able to harness data in order to not only do types of scholarly activities that have been traditional in the humanities, but opportunities where the humanities can inform the way we explain our science in order to have a greater impact on our nation and what I would call civil discourse. So I'm really excited about this. I was incredibly humbled to be named the inaugural dean. It's a big job. Starting a new school is not something that a university does very often. We're not exactly sure if it's been 50 years since the last one or 90 years. We're trying to track that down, but clearly it's a historical incident. And so there's no cookbook on how to do this, but I'm going to share my contact information through PyData Triangle, and don't hesitate to reach out for a conversation. I'm sure I'm going to be busy for a while getting the conversations done in an orderly fashion, but I just wanted to say hello, and I'm really eager to hear you all provide feedback from the front line, so to speak, and tell us what do you need for us to train the students in. I think my experience at RENC has taught me that we need students who are really trained in how to go to the cloud, how to use GitHub, how to use Python, how to use R, how to use it. So it's a high load skill set. But clearly this talk was fantastic. Thank you. We use graph databases every day in our research, and we think that that's one of the secret ingredients, and we use them because they're highly flexible in allowing you to hook together data that's very disparate but yet related to one another. So with that, I'll maybe answer a question or two, but I think I'm pushing the 5 minutes now. Thank you all.
And this is Mark. Could you say something about where the School of Data Science is going to be located on campus, and something about the departments and schools that are the big three supporting you? So
the 3 units that I see as, and I'll even maybe say 4 units that I see supporting the school. Supporting is maybe not the right word. It's more partnering with the new school. So computer science is one, statistics is another, applied mathematics, and biostatistics. We also want to have a very close relationship with SILS, because data science and information and library sciences are 2 different things, but there is a considerable overlap, particularly when you start thinking about how information affects society. So we want to find close partnerships with those units, but we don't want to restrict ourselves to solely those units. So I've already, tonight, while I was listening to the talk, which was excellent, I was also answering questions from people from School of Public Health. Is there an opportunity for us to hire joint faculty in that space? I fielded 2 or 3 questions from other units around campus, so including centers and institutes. So we're really trying to think of this as a pan-campus effort where the investments, and when investments are mentioned, you always want to know where the money's coming from. I think it's going to come from a lot of sources. We got a small amount of money from the legislature this year. I don't know if that's formalized yet, but at least we have progress. And the university's making a substantial investment. And so I'm hoping that we can find ways of using data as a unifying theme to bring together many disciplinary expertise, people across the campus. And indeed, I just got off the phone or off the Zoom with a colleague over at Duke. I think across universities, we want to be able to start putting together teams that tackle really hard, daunting problems for society, including things like, global warming and public health. Does that answer the question, Mark?
Sure. When will you start receiving or accepting students, whether at the undergrad or graduate level?
So it's a little bit up in the air right now, but we're shooting for, in at least in the public statements that my leadership has put out, that we're hoping to start enrolling students in 2023. I think there are students that are on campus right now that will be vectored through a series of courses so that when we start to accept students, they can be early acceptances which have already fulfilled some requirements. Again, everything in academia takes longer than I would like because we have a lot of discourse to have to conduct to be able to find the right path. But I do think that there's a general agreement that the School of Data Science and Society is going to draw on courses that already exist to some degree, as well as hiring new faculty. So I'm hoping that we can move pretty quickly. We already have some programs that have been approved and have started formation, and including one at the undergraduate level for a minor, which is currently housed in the College of Arts and Sciences. I'm meeting with the new dean of the College of Arts and Sciences tomorrow, and we'll work through how we're going to cooperate on that. For inviting me. I very much appreciate it, and I hope you don't hesitate to reach out to me, including possibly making introductions to other folks that I should be talking to around the Triangle, or even the state writ large.
It sounds very exciting. Really
Thank
does.
you. I'm excited and a little daunted as well.
Thank you so much, Stan, for this lightning talk. Really appreciate it.
Thank you.
All right. Mr. Peter, if you're ready, we can go ahead and start with your lightning talk, if you don't mind.
Yeah. No, thank you very much for having me. I would like to share my screen if that's possible.
Absolutely.
Yeah, I'll try to do that. Let me know if you can see it.
Yes, we can. Thank you.
Okay, great. So just to add something to what you said in the beginning of the meetup about having personal meetups again as soon as possible, I'm actually pretty glad that this one's remote since I'm in Dublin, Ireland. Originally, actually, I'm from Budapest, Hungary, so even a bit further away from you. But I'm here to make a talk tomorrow at the EuroPython about basically the same topic that I'm going to talk to you about, which is like a series of tools that we built in our own early stage startup called Vizu. And Janle was kind enough to promise me that I might be able to do a proper meetup talk later on. I still hope that for that occasion it's going to be remote, otherwise it will be a little harder to arrange for me. But to keep the long story short, so we basically created a generic chart morphing engine. So why we did that, I mean, I don't have time here to elaborate, but we did. We built it from the ground up. Basically, all the different types of charts are based or drawn on the same rule set. This is what allows us to to morph from one type of chart to the other, and that's like a capability that we try to build upon, some very central point of what we do at Vizu. So obviously the animation or the role of the animation is with storytelling and making people comprehend data stories easier. So I mean, with the 4 charts that I showed you in the previous slide, it's not much. So I mean, just by playing this short animation, the connection between them becomes crystal clear without me having to explain anything. And I'm pretty sure those of you who have to present your findings, present your charts to others, especially non-data scientists, have to spend quite a lot of time with explaining what we see. Also, there are actually plenty of benefits that the animation brings to data visualization. We feel that it's pretty similar to the change between movies and images. So you can dig into components of a composite index or see just parts of like basically turning one single chart into a story, see changes over time as in a racing bar chart, and zoom in on details, create context, while because of the animation, the viewers don't lose that kind of context when you're showing the data from different angles. So we were thinking a lot about how to productize this capability, and basically we identified a crucial problem regarding data scientists. But I mean, I'm not a data scientist, so you might contradict me on this. But actually, based on this resource that Anaconda released a year ago within the State of Data Science, it turned out that, well, actually, this whole storytelling aspect and delivering the insight, so like a lot of time is spent on it. It's very important for companies. Whereas still, most of the data scientists feel that the company leadership have a lot of trouble understanding the stories they tell. So we started building towards solving this problem. We have an open source technology. The core engine is in C++. We used it in-house to build stories to demonstrate the capabilities of our technology. They got quite popular, especially on Reddit and some other platforms. Then we released a JavaScript library for web developers last September, which got around 1,500 GitHub stars pretty soon and a lot of positive feedback. And just like 4 months ago, even a little less, we released our notebook integration for data scientists. And we call this tool IPyVisu, and I'm going to show you some example of its use like in a minute or so. So the embeddability and the whole open source approach that we took allowed us to, become available in all these platforms within 3 months. If you miss any other notebooks, other platforms that you use that you feel IPyVisu or Visu would be a good fit for, I mean, just let me know in the comments. I'm actually very curious about that. We're working on the Streamlit integration as we speak. So yeah, let's go. Let me show you like a super simple example of how this whole thing works. So this is like a story that I've put together. We use pandas, obviously. So if I run this cell, nothing really happens, but we just initiate everything and load the data, a CSV file in this case, to the data frame. Just to show you what's in there, it's basically some bogus sales data from a company that has 4 different regions, 4 different products with sales and revenue data. And so to draw a chart in Visu, you can set the width and height of it, and then you have to initialize it. And then you basically just add the data, and here we filter it. So first we're going to see the shoes, and then we put the series, like the region, on the x-axis, and this is what we do here. And just by running this cell, the chart appears. This is a vanilla Jupyter notebook. I just use a special type of CSS to show the results and the code side by side. And so in the next phase, the only thing we do is we add handbags to the mix. So we modify the filter. And as you can see, Visu will already animate between the states, and then you can see the shoes next to the handbags. Then we're going to add the third category of products, which are gloves. So here we modify the filter that it doesn't include accessories. And then at the last stage, we just add the accessories. So we have the sales number of all products per every region. But obviously, it's not only about how many items you sell, but also how much revenue you got. And in order to change that, we will just switch the revenue on the y-axis and also on the label, and change the title accordingly. And so it is a really important match. So to see how the chart changes, and obviously there are plenty of things that changed here because yeah, the revenue results are pretty different from product results. And then we can just, with calling the animate function twice, or method twice this time, we will just rearrange the chart in a way that it aggregates all the data independently from the regions and shows it on the chart. So it's like, I don't know how many animated charts have you made before. According to like what I've heard from other data scientists, it's not that easy to do it with other tools, especially in Python. So you can find it on GitHub. It's called IPyVizu. We prepared with a step-by-step tutorial and plenty of examples for you to start using it. I mean, if you look at the examples, you have the static charts here. You even have animated charts, and you can click on any of those. And yeah, the animations are not Visu, but some video that can be lagging, especially when I share my screen. And so if you click on any of those, you'll get to the code. And you'll be able to understand how that chart was created. So we are actually, as an early stage startup, very keen on further developing what we do in order to fulfill expectations. And so I'm actually very, very happy to present something that I originally intended to announce just tomorrow for the EuroPython conference audience. But since I got this chance, I had to tell you that we added two crucial features now. First one is that we are going to have presets. So this is the JavaScript version. I'm sorry about that. My our CDO is actually working hard around the clock, so it's past midnight back in Hungary, to make it available for the IPyVizu documentation. But basically, and we have some issues here with the titling, but basically now you are going to be able to just determine the type of the chart that you want to build, and then add what's required to that specific chart type, because we heard that it's easier than just using the generic engine that is behind Vizu, or that powers Vizu. And the other very, very important new feature that we're going to add is called IPyVizu Story. Here's an example of it. It's almost the same code, but we have some a story object here and some slides. But as you can see within the slides, it's basically the same type of code that you saw before. And so at the bottom of the notebook, you have this thing. And this is already a fully fledged presentation that you can use to present your findings, an animated presentation that you can move like back and forth between predetermined steps, even with your keyboard, even with a clicker. So it means that whatever you found in Jupyter and want to show your peers, we hope it's going to be much easier to share and present this way. And it's going to be much easier, obviously, for them to comprehend what's going on. So this is all that I wanted to share with you for today. Obviously, this is also on IPyVizu Story. We just released it like 6 hours ago. So it's fresh out of the oven. I'm pretty sure it's going to be a little bit rough around the edges, but I still hope you're going to like it. I'd be happy to take any questions. Actually, if you can pay a visit to our repos and drop us a star, I would definitely appreciate that. And for those of you who have to do this kind of thing, so like present the results of their findings, ad hoc analysis and things like that, if you could just go to this link right now and spend like 2 minutes filling out a short and sweet survey about how is it going for you, that would enable us to learn a lot, and I would definitely appreciate that. So I hope I'm not out of time here, and yeah, I'm happy to take any questions that you might have. It's just so strange. I can't see anyone, so I'm talking to my screen here, and yeah.
Bravo presentation. I mean, lightning talk, Peter. Really like it.
Thank you. Thank you.
Yeah, I believe in the chat, several of us expressed, big interest in learning this IPyVizu, in your open source GitHub repository. Pretty cool.
Thank you. Thank you very much. So this is my contact, and let me just really quickly copy and paste here the links for the 2 repositories. And also, I know people hate surveys, and I understand and they understandably do, but I can promise you it's going to be short and sweet, and you can help us so much. So pretty please, if you can just have 2 minutes of your time. Seems like if I copy and paste that here, it's gonna end up with a very strange font. So let me do a little bit of removing the, yeah. Okay, yeah, this one works.
Yeah, I did not know, Peter, you are located out so far away from Triangle in the United States. Where's your location again? Don't mind.
Well, I'm no, absolutely not. So I am right now in Belfast, Ireland. I'm sure you've heard about this city. And originally I'm from Budapest, Hungary. It's Central Eastern Europe. So here it's only like midnight. Back at home, it's already 1:30 in the morning.
Oh, thank you so much for, be with us. I didn't know we have different time zones. Now I know. I'm feeling so appreciated.
No, I'm glad to be here, and this is, let's say, the upside of having virtual meetups. So it would have been a hell of a lot more different to get there, and to you, but obviously a more full experience to get to know you. But I'm still very glad, and I hope I'll have a chance to make a proper presentation about what we do and why we came up with this whole concept of the generic charting engine and all this stuff. But thanks again for having me.
Absolutely. Thank you, Peter. We'll definitely let you know. We'll facilitate a better time for you to give us a full presentation. We're very looking forward to that.
Thank you, Jan-Leif. Thank you very much.
All righty. I think we are we have gone over 10 minutes, but I think we had really good time. Hope you guys had really good time in this event, Triangle PyData event in July. So